Hey there, Mr. Weaver here, and this is lesson 3 of our geometry unit, the Pythagorean Theorem. After this lesson, you need to be able to use the Pythagorean Theorem to solve for side lengths of right triangles, and you need to be able to use the Pythagorean Theorem in context. You'll know you're successful after this lesson if you can use the Pythagorean theorem to solve for missing sides in and out of context. The first part of this lesson is to know the parts of right triangles. So a right triangle is a triangle with a 90-degree angle. Generally, it's going to be indicated with that little square in the corner. It doesn't always show up, but usually it will be there. Sometimes it might be marked as 90, or they might tell you it's a right triangle without putting it there. Either way, it's going to have one 90-degree angle. Next, there are two words you need to know about parts of the triangle. So we have the legs of a triangle. Those are the two sides that connect to form the right angle. So we have our leg and our leg, two legs. The other side is called the hypotenuse. It is the side opposite of the right angle. So if you find the right angle, go across the triangle to the other side, that is your hypotenuse. It is the longest side of a right triangle. So your right triangle has two legs that are the short sides, and the longest side is called the hypotenuse. Now, with right triangles, we can use what is called the Pythagorean theorem. This only works for right triangles, so if your triangle is not a right triangle, it's not going to work, so don't use it. But what it says is the area of the square on the shortest two sides add to equal the area of the longest side's square. So if we have a triangle, if you were to actually draw squares on the side, and you took the area of a square that was along the shortest side and added it to the area of the square on the next shortest side, add those together, you are going to get the area of the square that's on that longest side. In other words, we have a squared plus b squared equals c squared, which is what you're going to see from now on. That is what the Pythagorean theorem says, and it can be useful when we're trying to figure out what missing side lengths are for our right triangles. So for our Pythagorean theorem, since we can use it to figure out unknown side lengths, I can figure out x here because it's a right triangle, and I can use the Pythagorean theorem. So I know that 7 squared plus x squared equals 25 squared. So the squares of the two short sides added together equals the square of the longest side. So for this one, let's actually draw squares. So I know that that side of the square was 7. If it's a 7 by 7 square, the side length is 7, so the area must be 49. For the x, I don't know what the side is. It's x, so the area must be x squared. And then for my longest side, 25 is the side length, so the area must be 625. Now, if I take those areas and add them together, 7 squared is 49, 25 squared is 625, and x squared, still just x squared, I can now solve for x. So to solve for x, I would subtract 49 from both sides, and I would find that x squared is equal to 576. Then, to solve for x, when you have an x to the second power, you take the square root. So if I take the square root of both sides, the square root of x squared is x, and the square root of 576 is 24. So that missing side must have been 24, giving it an area of 576. And then if I were to work forward, I know my 7 squared is 49. 49 plus 576 is 625, so my missing side must be 24. If I want to use Desmos to solve for that square root, at the bottom where the keyboard button is, click it, square root is next to the pi symbol in the bottom, so type that, and then we wanted 576, and if we use it as a calculator, it equals 24. Now it's your turn. Pause the video and see if you can figure out what the missing side is if you are given two other sides of 5 and 13. So we know 5 squared plus x squared equals 13 squared. So 5 squared is 25, 13 squared is 169. If we subtract 25 from both sides, you get 144. X squared is 144. Take the square root. You should have found that x was equal to 12. Let's look at another example, this time where we don't know what the hypotenuse is. So I have the square root of 3 as one side, 4 as another side, and then I'm missing my hypotenuse x. I do know that the square root of 3 squared plus 4 squared is equal to x squared. So for this one, let's use Desmos as our calculator and how you can easily keep track of what you're doing using it. In Desmos, I'm going to type in my two things in parentheses just so I can keep track of them. So I had the square root of 3 squared plus 4 squared. If you notice, when I do that and I type it in, it automatically tells me what the answer is. So I know that the area of that longest side is 19. Then, to figure out the square root of 19, I can just go down a line and type it in. I know that my answer must be 4.36 if I round it up. So I just typed in the problem in one line and took the square root of the next line to get my answer. So back here we had the square root of 3 squared plus 4 squared is equal to x squared. So 3 plus 16 was our 19. Then took the square root of that. We get the square root of 19, which we said was 4.36. But if it doesn't come out nicely, one thing you can do is just leave the square root as the answer. So I could just say that x is the square root of 19. That is perfectly acceptable unless it tells you to round to the nearest tenth or round to the nearest hundredth. Now it's your turn. Pause the video, see if you can figure out what the value of x is. Use Desmos as your calculator if you need it. Let's check. You should have got the square root of 38 as your answer, which comes out to be about 6.16 if you put that instead. Again, you could have just used the square root of 38 as your answer. To get that, square root of 2 squared plus 6 squared equals x squared. So 2 plus 36 is 38. Take the square root of that, and we get our answer. Now let's look at a problem in context. Pythagorean Theorem is very useful in context, especially when you're trying to find the distance between two things to see if something works or not. So a painter leans a 15-foot ladder against a house that's 12 foot tall. To be safe, the ladder must be 5 feet away from the house. Is the ladder tall enough to reach the roof? So for word problems, I generally like to draw a picture. So here's the edge of the house. It's 12 feet tall. And we know there's a ladder that's 15 feet leaning against it. The ladder must be 5 feet, but I want to know if 15 feet is actually long enough to get to the roof. So I'm going to pretend that I don't know the ladder is 15 feet and see what value of x would take me to exactly the roof. If that distance is more than 15, then my ladder wouldn't be long enough. If it's less than 15, then my ladder would be tall enough to get to the roof. So let's solve for x. I know that 5 squared plus 12 squared equals x squared based on the Pythagorean theorem. So 25 plus 144 is equal to x squared. 169 is equal to x squared. And then if I use my calculator, take the square root of 169, you find that x is equal to 13. So that distance there is 13. The ladder is 15. So we only needed 13 to go from the ground to the roof, but my ladder is 15. So yes, the ladder would be tall enough to reach the roof. The distance only needed to be 13 feet. The ladder's 15 feet, so it would reach. Pause the video one more time. Use the Pythagorean Theorem to figure out how tall Jorge's TV is. This one, don't leave your answer as a square root. Solve it to the nearest tenth, which is 1 decimal place. Let's check. You should have found that it was about equal to 12.1. If you see the symbol that looks like a squiggly equal sign, that means that it is about that number and it was rounded off. That symbol shows up quite a bit, especially when you're rounding off square roots. So Jorge's TV should have been about 12.1. If we had drawn a picture, we can see that it's a diagonal of 14 and 7 inches wide. So how tall? That's our x. 7 squared plus x squared is 14 squared. Remember, the two legs are what you add together to get to the hypotenuse. 14 is the hypotenuse. 7 squared is 49. 14 squared is 196. I would need to subtract and get 147. And then if we take the square root, we get 12.1. In this lesson, we learned that the Pythagorean theorem states that in right triangles, the area of the square of the two shortest sides, which are the legs, they add up to the area of the square on the longest side, or the hypotenuse. So in other words, a squared plus b squared equals c squared. And then a and b are your legs and c is your hypotenuse. The Pythagorean theorem only works for right triangles, and it has many uses and contexts. So anytime you want to find the distance between 2 points, you can use the Pythagorean theorem by taking your distance, making that the hypotenuse, and then making a right triangle. For example, if you worked for a tent manufacturer and you needed to know how much rope to include, where it's tied to the tent and it helps the tent stay up, you don't want to give them too much, but you don't want to give them too little. You could use the Pythagorean theorem, calculate the length of rope needed just based on how tall your tent was and how far away you need the stake to be in the ground. That'll tell you how much rope you need to get it exact. Then you might want a little more so you can make knots, but you're just using the Pythagorean theorem. So the rope would end up just being the distance between the stake and the tent. It has many other uses as well, and you will start to see different contexts. But again, anytime you want to make a right triangle, the Pythagorean theorem can help you find missing distances. After this lesson, do you know how to use the Pythagorean theorem to solve for missing sides in and out of context? If you're not sure about this, go back and look at some of the examples to figure out how to use it to find missing side lengths of our right triangles. And that's the end of lesson 3 on the Pythagorean theorem.